Atlantic water. This is an M times N rectangular island that borders both the Pacific Ocean and Atlantic Ocean. The Pacific Ocean touches the island's left and top edges, and the Atlantic Ocean touches the island's right and bottom edges. The island is partitioned into a grid of square cells. You are given an M times N integer matrix heights where height RC represents the height above sea level of the current cell at coordinate RC. The island receives a ton, a lot of water, rain, and the rainwater can flow to neighboring cells directly north, south, east, and west if the neighboring cell's height is less than or equals to the current cell's height. The water can flow from any cell adjacent to an ocean into the ocean. Return a to-do list of gradient coordinates results where results I is equals to RC denote denotes that rain can flow from cell RI to RC to both uh, the Pacific and Atlantic Oceans. So this is how our oceans look like according to the, and this is an example. So this is where our Pacific Ocean is and our Atlantic Ocean. So we're supposed to go look at list, use the list of the the cells that get us from one end to another. So here, so this is our output. It's a 2D list of grades. So we and also this one's a simple one. We have one, so that's 0, 0. Well, let's get into this. Let's make an edge case. Edge case. What's it called again? Heights. Okay. If heights. No, if not heights. Or not heights. Index 0 is nothing at its index 0. Return our empty list. Oops. Dimensions label. So let's call our rows M and N as our columns. The len, that will be len of heights and len of heights. At heights at index 0. So this is easy. So our len of heights, that will be, so for example in this case, that will be, how much do you have here? That will be our row 1 2 3 4 5. 1 2 3 4 5. Our len of heights in index is 0. We just go to the first one and check how much columns do we have. 1 2 3 4 5. 1 2 1 2 3 4 5. So now let's get into this. So let's make our sets. Our sets to start our cells. Oops. Let's call specific, let's say fake, reachable, and set. And they call Atlantic, reachable, and give it set. Now let's make a DFS helper. DFS helper function. So let's call it a def DFS. Let's name our column RC and row and column and reachable. That will be for either one of these. Reachable. Let's add so reachable that add RC. So whenever we call into this function, let's add them. So now let's move on to our directions. So this is so that we call them directions, and then it goes to our list, and then down, up, -1, 0, 0, 1, right, and then left. Let's call them in order. In order. Down, up, right, left. So now let's let's go to those directions. So that would be for DR, the road, DC, and directions. So our new NC and no NR and NC will be equals to DC will be equals to DR plus R plus R, and then DC plus C. So now let's check if in bounds, and then visited, and if the new cell is greater than or equals to our current cell. So that's so this one. So the first part is new. It's the same format. So if 0 is 0 equals to NC and R is greater than R. Greater than M, which is our and 0 and R is less than 0 goes to NC, which is also nope. This is less than. same format. So and visitor will be um, NRNC, not in reachable. And our heights, basic heights, NC and NC is greater than or equals to heights dot wait no RC our current cell. So now let's call in the function now. DFS N R N C and then reachable. And that's basically it for our DFS function. Let's move out of it and hold on, line up. Let's move out of the function, and now let's go to our Pacific and Atlantic list. For R in the range of M, let's call it DFS R and then O, reachable, and then DFS. Oops, this is Pacific reachable. Pacific reachable, and then n -1. So this will be the top, no, the leftmost, and this one will be the rightmost. So reachable, and then Atlantic, reachable. So same easy format over here. So now let's move down to for C in the range of M, DFS no O C, and then same Pacific, and then Pacific again, reachable, and then DFS. So this will be the so this one is the upmost, this one leftmost, this one is the topmost, top first column. This one will be since we used, wait, hold on, this is an N. Why do you use an M? So M -1, C, Atlantic. Reachable. So now let's make our results equals to the list, a list that contains Pacific and Atlantic values. So Pacific reachable, and hold on, what's the end? Atlantic reachable. Return result. Is there any mistake? Let's see if it works. Runtime error. Says heights is not defined. Where? Oh, over here, heights. It says expected 010203. Let's see what's the issue here. Hmm. Hold on, Pacific. Hmm. Let me summary to see how much cases have passed it. 7 out of 113. So it may be something to do with this. Let's see. Up, down, up, negative 1, negative. Let's check to see if it has all the heights. Oops. Wait, hold on. Whoa, I think this may be it. And that was it. So now we can finally get to this heights over here. And boom, it's been accepted. um, and the time and space complexities for both of these. Hold on. Time complexity is m times n times column space space complexity is also of m times n recursion start so let's submit it to see if it's going to pass all cases. Because right here. And that's it for this problem.